In the barren, frozen wilderness which reaches above the Arctic Circle, a new system for continental defense is being built under conditions where ice and snow and isolation are part of everyday life, where man must learn to live with nature before he can learn to defend himself against a living enemy. This is the DEW Line, a carefully planned system of radar stations for detecting approaching enemy planes while they are far beyond our borders, stretching from the northwestern limits of Alaska across Canada and on to Baffin Bay. This distant early warning line is being constructed by the Western Electric Company with the help of other units of the Bell system, another tremendous communications job for the nation's security. This is their 1955 progress report. To establish a base in this wilderness takes men and equipment. To reach this cold and bleak Arctic wasteland in the beginning, it was necessary to use aircraft to supply and maintain the men at these bases, stretched across the roof of the world. Paradropping of basic needs was often the only means of supply available, until larger equipment and facilities could be readied. As the early camps became more firmly established, larger buildings were brought in to provide the basic comforts and means of existence to the personnel who were to live and work through the long, cold Arctic nights. Since local weather conditions played an important part in the well-being of the men and the scheduling of supply shipments, it was a matter of great importance to establish temporary communication to keep in touch with the outside world. The D4 tractor was packed and loaded into a U.S. Air Force C-119 flying boxcar. Once over an isolated campsite, the tractor was dropped from the rear door of the plane to float gently down to earth. This method of delivery proved most successful. Once, however, a frozen parachute meant the loss of a tractor and the scheduling of another mission with a replacement. Until the arrival of D4 tractors such as this one, construction was virtually at a standstill. As soon as the tractors had landed, eager workmen swarmed over them to put them in working condition. With this valuable piece of equipment on hand, the men now set about the task of clearing snow from the top of the flat sea ice to provide the landing room needed for cargo planes. Special teams of personnel were brought in to test the load-bearing capacity of the ice field on which the heavy airplanes were soon to land. It was a welcome sight when these giant U.S. Air Force C-124 Globemasters started to deliver the heavy equipment that was needed to begin construction of the permanent airfields. These huge planes were called upon to deliver massive equipment that could reach here at this time only by air. Many types of machinery were needed. This dumpster to carry gravel, this giant crane to scoop up and load the gravel and rock, this truck, in addition to dumpsters, to haul it many miles from the natural deposits to its final destination, this grader to move and place the thousands of tons of gravel which go into the making of vital airstrips. Day by day, foot by foot, the airstrips lengthened, using this heavy equipment that was delivered by a gigantic airlift. The completion of these permanent landing fields would permit more and more routine missions, which kept the men supplied with the necessities of life. By summertime, many of these airstrips were completed. The early problems of obtaining fresh foods were now solved. Now it could be had in larger quantities: potatoes, cereals, meats and vegetables. All this to make a well-fed man a better worker. A method of delivering essential fuel was needed where there was yet no landing strip. Pilots of chartered airlines took over with courage and ingenuity, and big air transports would roar in from the skies overhead, dumping their cargo for the men ashore. Vital fuel to keep the DEW line forging ahead. As more and more deliveries were made, supplies from the planes were stockpiled for future use. The spring and summer of 1955 saw the preparation for a gigantic sea lift northward. On the east and west coasts of the United States and in Canada, ports were bursting with material awaiting transportation. Petroleum products in vast quantities were stacked in ever-increasing numbers. This was to be turned into heat, the life's blood in areas where heat means survival. Lubricants and fuel for the trucks, tractors, graders, and cranes that would be the muscles for overcoming the wilderness. To these ports from the length and breadth of the land came material: trucks, cement mixers, graders. Crates of building panels, storage tanks, steel for hangars and garages, cement and cans, material from manufacturers all over the United States and Canada. All this was loaded on ships of the U.S. Naval Service under the control of the Military Sea Transport Service. The job of procurement was one of great complexity. Since the Arctic sea lanes are open for only a short period during the summer, timing was of paramount importance. Canned foodstuffs in large quantities could now be sent northward. Even this giant rock crusher, the largest single piece of cargo, had its place in the scheme of things. During the summer months, it was necessary for an icebreaker to clear the path for the supply convoy. Many times the operations were hampered by the ever-shifting ice fields. As the ships neared their destinations, preparations had to be made on the beaches to receive the thousands of tons of supplies. Frogmen from a Canadian icebreaker were given the task of keeping the beaching areas clear of underwater obstructions. Braving frigid 30-degree water temperatures, they blasted away submerged rock in the area over which the landing craft must pass. As the ships of the convoy anchored off their destination points, the huge task of unloading the many thousands of tons of cargo fell upon the shoulders of specially trained members of the U.S. Army stevedoring crews. They were called upon to unload these difficult cargoes in as short a time as possible, since Arctic waters would soon be closed. 24 hours a day, these men toiled to finish the job. At times, LCMs had to pick their way through the drifting ice floes to get to the beach. At other times, their job was somewhat easier because then the water was free of ice. The beaches which you saw being prepared earlier are now covered with men and landing craft, bringing to the Arctic shores the material which will enable them to eventually complete the facilities of the DEW Line. The careful planning and marking of material at the loading ports were now showing results as the cargo was easily separated and stored on the beaches. At some unloading areas, exceedingly high tides made conventional landing craft virtually useless. To overcome this, the Army moved in experimental vehicles such as this bark, capable of carrying large payloads directly from shipside to the stockpiles on the beach. While these stockpiles on the Arctic shoreline were growing, the Mackenzie River system, which flows through the wilds of northwest Canada into the Beaufort Sea, was also the scene of DEW Line activity. Here at Waterways Canada, the railhead connecting with the river route northward, material of every description was transferred from trains to barges and transported northward to Fort Fitzgerald. Rapids in the river system below Fort Fitzgerald made it necessary to unload these barges for reloading onto trucks to portage a distance of 25 miles. Everything using this route to the Arctic Ocean had to follow the same portage. Even this ocean-going tugboat had to be loaded on trailers to circumvent the rapids. The tug was relaunched at Bell Rock, where it took up its permanent duties of ferrying these barges, which when loaded, moved directly to the sites. The concerted efforts of the many men was now evident in the acres of material and thousands of drums of petroleum products stacked in wait for the cold Arctic winter which was to come. An additional transportation route was established by blazing a trail across the Arctic wilderness from Circle, Alaska, north to the Arctic Ocean. It was an unusual sight to find convoys of trucks of this type inching over terrain where no roads had existed. Even more unusual was the sight of this land cargo train, nicknamed the Monster. Its capability of maneuvering over frozen lands was made possible by its ingenious construction, each wheel being individually powered by its own electric motor. The advent of warm weather brought new hazards to additional road construction. Ground that was previously frozen was now soft and unstable. Often it was easier to build a road through a shallow lake than to go around it. Mud, rocks, snow, and ice shortened the normal lifespan of heavy earth-moving equipment to a fraction of its time. This meant that thousands of dollars worth of spare parts and repair facilities had to be maintained at each site to keep this equipment at work. Some of the empty oil drums that had accumulated were welded together into sections, forming long culverts which were placed in drainage ditches. The road construction crew then built their roads over these culverts. Vehicles of many types were used for transportation in the Arctic. Track vehicles, such as the snowmobile, proved most dependable for all Arctic conditions. Vehicles radically different were getting their first taste of the conditions under which they were to be used. The Seawolf was at home in the water as well as on land, and particularly useful when the going got rough. The movement of material inland from the beaches to the site locations necessitated many miles of extra roads, often up the sides of mountains or across marshy flatlands. A method was devised to assemble building modules in special tents. A frame was erected and then covered with canvas or plastic. These centralized assembly areas permitted the construction of building modules in an economical production line method. Prefabricated insulated panels were assembled into completed modules. This ingenious method of construction allowed buildings to be assembled while roads to the sites were under construction. As the basic units were completed, they were moved to a storage area where interior finishing was accomplished. Temporary heat piped into the modules by Herman Nelson heaters made it possible to work inside in spite of the cold weather. As soon as a sufficient number was completed, they were placed on sleds, hitched together, and cat trained to the various sites where they were to become part of the permanent building train. Cat training modules from a central area eliminated the need for assembly facilities at some of the sites. As the preparation of modules progressed, pilings were set up at the actual building sites. Holes were first made in the frozen tundra with steam jets. The pilings were set and driven deep into the permafrost. The resulting mud and water were replaced and allowed to freeze, thus providing a permanent foundation. A complete train of buildings was made up by sliding modules onto the foundations and connecting them. Another type of building foundation was the sill. This differs from the piling in that it sits on a gravel insulating pad, which is used to keep the heat from thawing the ground. Bulk fuel oil storage tanks were built at some locations during the summer months when it was easiest to pour cement outdoors. Circular concrete pads were first constructed. Footings were then poured. On these footings, steel sections were welded together, forming bulk storage facilities which in the future will eliminate the need for transporting petroleum products in small drums. By mid-September, the construction camps were well established in anticipation of the arduous task to come. The necessary supplies and materials to carry on this tremendous job had been sorted, inventoried, and stored to be ready for use during the coming winter months. Man had permanently made his mark upon the frozen wastes of the north. Looking down on his handiwork, he could see with his own eyes the equipment, the tools, the boats, the tractors and trucks, and planes and trains with which he had set up his home at the top of the world. He could now live here, work here. But all the thousands of tons of material thus far delivered will serve only to construct the airstrips and roads and to build the buildings which will house the complex electronic detection equipment to come. Much has been accomplished, but a great deal remains to be done until at last the long chain of these protective stations is completed and in service. The job has only begun, but it is a good beginning.